I'm Maass, and welcome to a very special interview with a very special guest. In fact, one of the most popular scientists in the entire world, Sir Isaac Newton, who had the pleasure to come from the past to the future to talk to us today. Great to be with you today. Well, Sir Isaac, let's get this thing started. When exactly were you born, and what was your childhood like? Well, I was born January 4th, 1643 in Woolsthorpe, England. My dad died 3 months before my birth, and my mom remarried when I was 3. I reunited with my mom at 12 years old when her second husband died, but I had to live with my grandmother for a long time. I'm so sorry to hear that. That must have been hard for you. Yeah, I've suffered with anxiety, insecurity, and bad behavior throughout my life since then. Well, you've certainly figured out how to move past those hardships, haven't you? Well, how about later in life when you started to get a college education? Oh yes, I attended Trinity College and Cambridge University up until 1665 when the plague outbreak shut the school down for 2 years. Regardless, I still earned a bachelor's degree and an MA at the end of my college career. Fascinating. Moving on from that though, let's talk about your studies. Sure. I worked in the fields of physics, natural philosophy, alchemy, theology, mathematics, astronomy, economics, and optics. More specifically, I studied light, gravity, color, the planets, and calculus. I was a very big influence in the scientific revolution, if I do say so myself. In fact, I wrote books such as The Principia, which explains my laws of motion, gravitation, and the planets, and optics, which talks about light and diffraction. Okay guys, now we're outside, and we're going to start off by talking about the first law of motion. The first law of motion states that an object at rest will stay at rest, and an object in motion will stay in motion unless acted upon by a non-zero net force, right? Precisely. Essentially, an object will resist motion, meaning it has inertia unless something moves it. Here's an example. The soccer ball is still, right? But when I kick it, the soccer ball had inertia, but when I used a non-zero net force, in this case being my foot, it started to move. Now, would gravity count as a force? Of course. Let me show you this example. If I throw this tennis ball into the air, it moves because the gravity will pull it down after I throw it up into the air. Oh, okay. Now I understand. Now what about the next law of motion? Well, my second law of motion states that an object's acceleration depends on its mass and the net force acting on it. The formula for acceleration is net force divided by mass, which can be used to determine different equations for mass and force as well, like net force equals mass times acceleration. Let me show you some examples over here. Okay guys, now we're on the driveway, and Sir Isaac Newton is going to show us 2 examples of the second law of motion. Okay, for my first example, I want to use 2 sports balls, a basketball and a golf ball. And for my first example, I want to roll them across the driveway to show that the lighter one, meaning the one with less mass, the golf ball, will accelerate more because of its less mass. I also have a second example. My second example is throwing them into the air instead of going on the driveway. So, as in the first example, the one with the less mass, used with the same amount of force as the one with heavier mass, will go farther up into the air. Okay, I think I understand the first and second law of motion now. Now let's talk about the third law of motion. Every action has an equal and opposite reaction, right? Right you are. Every action force has a reaction force, even if it isn't obvious. For example, if I push my finger against my other hand, my hand might not be moving, but it is exerting a reaction force which causes my finger not to push through my other hand. The action force would be my finger pushing on my hand, and the reaction force is my hand pushing my finger the other way, even though it's not moving. Oh, I see. How about another example? Oh, I got one. Let's push my finger against this table. Now the table isn't moving, of course, because it's too heavy, but my finger is pushing an action force against the table, and even though the table is not moving, it's exerting a reaction force. Yes, that definitely makes sense. Now that I understand all 3 laws of motion, let's conclude this episode. Mr. Newton, today was really fun. I learned that your 3 laws of motion happen whenever anyone does basically anything, and I also learned a lot about your personal life.